It began with a storm of voices, news anchors, podcasts, and social media feeds all shouting the same question: could this be alien technology? When the interstellar comet known as 3I Atlas appeared, curiosity turned into chaos. Some declared it proof that we were not alone. Others called it a hoax. The word alien spread faster than the facts ever could. But while the world argued, telescopes kept watching. Beneath the noise, quiet minds measured its light, traced its orbit, and saw not a spaceship, but a relic from another star. This was no message from an alien world. It was a fragment of one, older than our planet, drifting through the solar wind after billions of years of solitude. Why are we so eager to believe in other civilizations, yet so slow to see the beauty in the evidence before us? The universe already speaks to us, not through signals or secrets, but through the chemistry of its own making. Every element, every trace of light is a message written in the oldest language of all, nature itself. 3I Atlas is not a mystery to fear, but a story to listen to. And if we quiet the noise long enough, we might finally hear what it has been trying to tell us all along. Hello and welcome. I am Orion, coming to you from Infinite Universe NTH. Long before the Earth took shape, in a distant region of the galaxy where sunlight never reached, a small body of ice and dust was born. In that place, temperatures hovered close to absolute zero, and matter moved slower than thought. From the remnants of ancient stars, grains of rock and frozen gas gathered together, pressed by time into a fragile nucleus. That fragment, silent, ancient, and unclaimed, would one day become known as the interstellar comet 3I Atlas. For billions of years, it journeyed between the stars. No sunlight, no steady orbit, only the quiet rhythm of the cosmos guiding its way. It traveled through regions once lit by stellar explosions and through cold clouds where new suns were beginning to form. Through it all, it remained perfectly preserved, a frozen archive from a distant corner of the galaxy. Then, sometime in our own era, a faint gravitational pull changed everything. The attraction came from our sun. 3I Atlas began to fall inward, accelerating to nearly 60 kilometers per second, fast enough to cross the distance between Earth and the Moon in only a few hours. For the first time in ages, light touched its surface. Layers of ancient ice began to vaporize, releasing clouds of gas and dust that stretched thousands of kilometers into a luminous tail. Telescopes around the world turned toward it. In July of 2025, observatories confirmed that the object's orbit was not bound to our solar system. It was moving too fast, on a hyperbolic path that would eventually send it back into the deep interstellar dark. That trajectory confirmed what astronomers had hoped. This was a true visitor from beyond. What made it remarkable was not only where it came from, but what it carried. Its ices were rich in carbon dioxide, yet contained little water, suggesting that it formed in a place far colder than even the outer edge of our own system. Spectrographic readings implied that its materials might date back more than 7 billion years, older than the Earth itself. Viewed through the Hubble and later through the James Webb Space Telescope, the nucleus appeared small, roughly 5.5 kilometers across, a pristine fragment of another world coated with carbon compounds and metallic dust. Every particle on its surface preserves the chemistry of its birthplace, carrying within it the quiet memory of another sun. As it passed near Mars in October of 2025, orbiters turned their instruments toward the faint glow around it, the soft, hazy cloud known as a coma. Though delicate and difficult to capture, those images confirmed that 3I Atlas was active, shimmering as sunlight awakened the ice that had slept for eons. As 3I Atlas drew closer to the warmth of our sun, the instruments turned toward it began to reveal secrets no one expected. Every comet tells a story through its chemistry, and this one spoke in an unfamiliar dialect of the universe. The readings from space observatories showed that its icy layers contained far more carbon dioxide than any comet we had ever measured, and far less water. It was a discovery that puzzled scientists everywhere. In our solar system, comets rich in water are common because they formed closer to the early sun. But this one, with its strange composition, hinted at a birthplace in a region far colder and more remote than anything we know. This imbalance between carbon dioxide and water suggested that 3I Atlas formed at the very edge of its home system. A place so frigid that water could barely solidify while carbon dioxide froze easily. In those frozen outskirts, chemical reactions slow almost to stillness, preserving the ingredients of creation for billions of years. When the comet was finally ejected from that system, it carried with it the untouched chemistry of another star's nursery, a sample of conditions that existed long before our sun even began to shine. Then came another revelation. In late September of 2025, the Swift Observatory detected faint ultraviolet light, evidence of hydroxyl gas, a telltale fragment left behind when sunlight breaks apart water molecules. The presence of that signal confirmed what many thought impossible. There was indeed water escaping from the comet, but in an entirely new way. Instead of evaporating directly from the surface, the water appeared to be trapped in tiny grains of dust ejected into space. Sunlight then fractured those grains, freeing the hydroxyl that telescopes could see. This meant that 3I Atlas wasn't dry after all. It was alive with subtle chemistry, behaving differently from any comet we had observed before. The water was not simply boiling away. It was whispering out through microscopic, ice-coated dust, released gently as it raced toward the sun. That unexpected mechanism changed how astronomers understand cometary activity across the galaxy. It proved that even in the deep cold between stars, small bodies can store and release water in ways we had never imagined. The discoveries didn't stop there. Observations from powerful ground-based telescopes revealed traces of nickel and iron, metals common in comets, yet here they appeared in an unusual balance. At first, only nickel emissions were seen, shining as a faint blue spectral line. Iron, strangely, was missing. But as the comet approached the sun, that balance shifted. Iron signatures appeared and strengthened, showing that both metals were escaping at different temperatures. The explanation was elegant. The metals weren't pure. They were part of complex organic compounds that vaporized gradually as sunlight warmed them. Nickel, bound in a more volatile molecule, released first. Iron followed later, when heat finally reached its threshold. This pattern of emission provided rare insight into the chemical bonds linking organic and metallic materials, connections that form the foundation of planets, asteroids, and maybe even the building blocks of life itself. Each new discovery turned 3I Atlas from a curiosity into a living laboratory. It was no longer just a comet from another star. It was a messenger carrying physical proof of how differently the universe can build its worlds. For scientists, this was a gift, a real fragment of interstellar chemistry passing through our reach for only a brief moment. And as it continued on its path around the sun, one truth became clear. Every particle released from that glowing tail was a story, each atom a piece of a forgotten origin. 3I Atlas was not shouting its secrets. It was revealing them softly, molecule by molecule, through the quiet light that reached our telescopes. And for those who listened closely, the message was unmistakable. The universe is far more inventive than we ever dared to believe. When the first headlines appeared, they were not about chemistry or discovery. They were about aliens. A single speculative paper suggested that the strange metals seen in 3I Atlas might hint at something artificial, and within days that idea flooded news feeds and podcasts around the world. The comet was no longer a natural traveler from another star. It was suddenly being called a possible spacecraft, a messenger, a sign. For many, that explanation felt more exciting than any data could ever be. But inside observatories and research centers, the tone was different. Scientists examined the claims carefully, comparing results, repeating measurements, and searching for solid evidence. None appeared. The spectral lines of nickel and iron, the ratios of gases, and the faint ultraviolet traces of hydroxyl all matched the behavior of ordinary matter under extreme conditions. There were no signals, no artificial structures, no hidden machinery, only nature at work, beautiful and complex. The contrast between speculation and science was striking. In the public imagination, mystery always seems louder than truth. It spreads faster, demands attention, and promises wonder without proof. Yet, for those who dedicate their lives to understanding the cosmos, real wonder is found in patience, in the slow gathering of data, the quiet process of connecting facts that fit together like pieces of a cosmic puzzle. 3I Atlas became a symbol of that divide. On one side, a narrative built on excitement and imagination. On the other, a reality built on precision and evidence. Both were driven by curiosity, but only one could stand the test of time. The astronomers knew that extraordinary claims demand extraordinary proof, and this time, proof pointed to something far more profound than technology. It pointed to the creativity of nature itself. Still, the debate carried a lesson beyond science. It showed how deeply we long to connect with something greater, how the idea of alien life stirs both fear and hope. But perhaps that hope is not misplaced, only misdirected. Because every new discovery, every comet, every photon that travels across light years to reach our telescopes is already a form of contact. The universe is speaking constantly. We are only just learning how to listen. As the days passed, the loudest voices faded. The stories about alien technology lost their spark, replaced by detailed studies and calm analysis. And somewhere in that transition, a different kind of excitement began to grow, not from speculation, but from understanding. As the weeks passed, 3I Atlas moved farther from the sun, its brilliant tail fading into the black canvas of space. The instruments that once tracked every flicker of light now recorded only silence. Yet that silence carried meaning. For scientists who had followed its journey, the end of observation was not a farewell, but a pause, the kind that lets reflection take root. What this comet revealed in its brief encounter with our solar system was not a story of alien design or cosmic intrusion. It was a story of connection, of how even the smallest traveler can link worlds separated by impossible distances and unimaginable time. By November of 2025, its trajectory placed it near the orbit of Jupiter, where two spacecraft, the Europa Clipper and the European mission known as JUICE, turned their sensors toward the vast emptiness it had left behind. There was a chance that the faint traces of its tail, a thin veil of ions and dust, might brush against their instruments. If that happened, they could capture direct samples of material from beyond our sun, the first time humanity would ever touch matter born in another star system. The thought alone was enough to inspire every researcher watching from Earth. But even if no new data came, 3I Atlas had already changed our understanding. Its composition, its activity, and its unexpected chemistry forced scientists to rethink what they knew about comets, not as identical icy bodies, but as archives of diversity scattered across the galaxy. It reminded us that creation is not uniform. It is experimental, dynamic, endlessly inventive. In its wake, the comet left questions about how elements travel, how water persists, and how metals form bonds with organic molecules in the deep cold of space. Those questions will echo through future missions and generations of astronomers. As the comet continued outward, shrinking into invisibility, it became part of the background sky once again, another faint memory among billions. Yet its journey is far from over. In another star system, countless light years away, another civilization might one day see the same glimmer and wonder, just as we did. Perhaps they, too, will turn their instruments toward it, searching for meaning in the light of a distant traveler. 3i Atlas teaches us that not every message from the cosmos comes in a voice we expect. Some arrive in the form of motion, chemistry, and light, quiet, constant, and profoundly beautiful. The universe does not shout its secrets. It whispers them through the language of nature, patient and eternal. And for those who choose to listen, the reward is not just knowledge, but perspective. A reminder that we are part of a much larger story, written across time and stars. The comet is gone from view now, but its legacy remains. A moment of clarity in the endless dialogue between curiosity and creation. The next traveler will come, and we will look up again, ready to learn, ready to listen. Because wonder, it turns out, was always enough. Hello and welcome. I am Orion, coming to you from Infinite Universe NTH.